Hey guys, this is the lesson for April 7th. So here's what I'm going to do. We have three goals we're going to accomplish today. So as I make this video, we're going to attack each goal one by one. Okay, so we're going to take a look at your goal sheet. And the first goal I want to talk about is a bit of a review from yesterday, where we're going to talk about the location and charges of the three subatomic particles, protons, neutrons, and electrons. So let's just take a look at this. So right here, I'm going to hit stop share. So that's our first goal. And I'm going to share something else here, which shows a model of an atom. And this is called build an atom. So you see all this. So let's just focus on a couple things here. I don't need you worrying about this. Don't worry about anything on the right side. Okay. All I want you to do, and I'm going to hit reset. All I want you to do is focus on protons, neutrons, electrons, and right here. Okay. That's all I want you to focus on. Nothing here yet. We'll get to that. Don't worry. So right here, I'm going to build my own atom. And I have these three pieces I can work with. I've got protons, which you know are positively charged. P for proton, P for positive. Neutrons, neutral. See how neutrons, how they kind of go hand in hand, that prefix? And electrons, and they are negatively charged. So protons are positive, neutrons are neutral, electrons are negatively charged. And these three things are called the subatomic. So atomic means atom, sub means within or below, underneath, in that category, particles. All right, so let's build an atom. So you're going to see a couple things pop up. Just relax. Let's take a look. I'm going to throw a proton in here. Ask yourself, where should it go? Should it go to the nucleus or should it go to the outer orbits? Let's see. Whoop, I dropped it. Let's pick it up again. Oh, don't worry. Okay. Don't worry about ion. Don't worry about this. It went right into the nucleus. Okay. And it's positively charged. So let's see what happens if I pick up a neutron. What happens? Where does it go? Right into the nucleus. Same thing. So protons and neutrons go right to the nucleus. Again, don't worry about this. We'll get there. So the protons are positive, the neutrons are neutral. Where do the electrons go? They go to the outside. They are outside the nucleus in the orbits. And there's going to be different levels of orbits. The bigger the atom you'll see, the more orbits you'll have, okay? So the electrons are negative. They're located on the outside of the nucleus. The protons and neutrons are inside the nucleus. So protons are positive, neutrons are neutral, electrons are negative, and they're on the outside, okay? All right, so that's our first goal. That's our first goal we just accomplished. That was pretty much a review from yesterday's lesson. Okay, so I'm gonna hit reset, and then I'm gonna stop share for a second, and I'm gonna share that. Let's see what the second goal is. Second goal, recognize how and why atoms have an overall neutral charge. So we're going to look at here, why are all atoms neutral? And I will tell you this, I want you to get this statement in your head. Ready? Atoms are neutral. Nucleus is positive. Say it. Atoms are like rhythmic. Atoms are neutral. Nucleus is positive. Atoms are neutral. Nucleus is positive. Say it 10 times. Atoms are neutral. Nucleus is positive. Atoms are neutral. Nucleus is positive. Okay, that's part of the lesson. Now let's prove why. It's one thing to memorize. It's good. It helps to memorize, but let's prove why. Okay, so I'm going to hit stop share for a second. And let's see how atoms are neutral and nucleus is positive. So let's go to share screen again. Build the atom. Okay. So now we know where the protons, neutrons, and electrons are located, okay? Protons, neutrons on the nucleus, electrons on the outside. Let's focus now on the charges. We know protons are positive, neutrons are neutral, electrons are negative. So we need to make an atom. I don't want this thing called an ion. You're going to see this word ion. That's next week. We don't want an ion yet. We want atoms. So how do we make an atom? So let's say I throw in one proton, okay? And I will tell you this. I have one proton, and all of a sudden up here it says H, and that means hydrogen. Okay, we'll get to that soon. I wonder why that's happening. Well, I know why. You're going to learn it soon. But it doesn't say atom yet. I want it to be an atom. What do I need to do? Oh, wait a minute. Go back to your statement. Atoms are neutral. Nucleus is positive. So the nucleus is positive here. Let's give it a neutron. Okay, it's still positive because I have a positive thingy there and I have a neutral thing there, so it's still positive. But it doesn't say atom yet. I want an atom. Wait a minute. Atoms are neutral. Well, what do you think would cancel out this positively charged proton? Oh, an electron. Let's see if this becomes an atom. Bam, neutral atom. So atoms are neutral, nucleus is positive. The nucleus is positive. Why? Because I've got positive and neutral things. The neutrals contribute no charge. Honestly, they're there to kind of keep the nucleus together. They're like the guidance counselors of the nucleus. They kind of keep things chill in the nucleus, right? Like our buddy Mr. Lemieux, who tries to keep things chill, you know, down in that guidance office. He'll love that I gave him a shout in this video. So neutrons kind of keep things chill. They kind of keep things chill in the nucleus. You'll learn more about that next week. So ultimately here we have a positive proton, positively charged nucleus, and one negative electron. So they cancel each other out and makes a neutral atom. Okay, so let's make another one. Let's see. Let's see if I add another proton, what happens. Uh-oh. I don't have an atom anymore, but I have helium? Wait a minute. Let me do that again. I just changed the number of protons, and I have a new atom. Wait a minute. Replay. Changed the number of protons, and I have a new substance. Wait a minute. Wait a minute. I don't have an atom yet. I want an atom, I said, because atoms are neutral. But the nucleus is positive, but atoms are neutral. Let's see. Oh, that's right. Add a negative electron because I've got, watch this. Bam, look at that. There it goes. Don't worry about why it goes there. So right now I have, I'll add another neutron too. So right here I've got two protons. So I've got two plus things. And now I've got two negative things. Look what I have, a neutral atom, because the two positive plus plus cancels out the two negatives, because all atoms have to be neutral. So you see a pattern here. All atoms must have the same number of protons and the same number of electrons. Okay? So atoms are neutral. Nucleus is positive. All right, let's throw some more. Let's see. Let's put in another two more atoms. Let's put in three more atoms. Yeah, do I have an atom? Wait a minute. The identity is changing. Whoa, what happened here? Where was my helium? Remember, we're gonna get to this. Something to do with the protons must really determine what the element is. All right, let's stop there. Let's stop at boron, but it's not an atom. Wait a minute, I've got 1, 2, 3, 4, 5. Look at that top left corner. 5 protons. Nucleus is positive, okay, but only 2 electrons. Do we have a neutral atom? No, because I have 1, 2, 3. Look at that mouse up there. 4, 5 positive protons and only 2 negative electrons. So think to yourself, how am I going to make a neutral atom? I have to have boron though. I'm not, that's it. What I'm going to do is I'm going to add 3 more electrons. Am I there yet? Nope. I have 3 that cancel out, but I still have 2 more positive. That's why it says positive up here. And we'll do ion next week. Atoms are neutral. Nucleus is positive. We're not neutral yet. Oh no. Bingo, there you go. Atoms are neutral. Nucleus is positive. We'll put a couple more neutrons in there. And again, we'll get into why we put in a couple more neutrons next week. But again, the key idea is here, I need you to know an atom has to have the same number of protons, right, and electrons, because, say it again, atoms are neutral. Nucleus is positive. Atoms are neutral. Nucleus is positive. So once again, boron's got 1, 2, 3, 4, 5 protons, right? So I have 5 plus charges, and it's almost like fractions. You cancel things out. I also have 5 electrons. So this guy cancels out this one. This cancels out with this one. This and this cancel. This and this cancel. Red and blue cancel. Red and blue cancel. Red and blue, red and blue. They cancel out to what? Neutral. Atoms are neutral. Let's just do one more. Okay. Let's add 2 more protons. Will I still have boron? Oh, carbon. Nitrogen. My gosh, it changed, but I don't have an atom because I don't have the same number of protons and electrons. So let's see, I have 1, 2, 3, look up at the top left key, 4, 5, 6, 7 protons. And I have 1, 2, 3, 4, 5 electrons. How many how many electrons should I add to make it neutral? If I have 7 protons to make it an atom, I don't want an ion. We don't want to learn about that yet. I'm gonna add 2 more electrons. 1, 2, there it is, a neutral atom. Why? 1, 2, 3, 4, 5, 6, 7 protons. 1, 2, 3, 4, 5, 6, 7 electrons. And again, we do throw in a couple more neutrons. Again, you don't need to worry about why. How many neutrons in each one? That's next week. Just know the neutrons keep the nucleus kind of chill. That's all you got to know. Please don't question yet. We will cover that next week. All I want you to focus on is every atom has to have the same number of protons and electrons. Why? Because atoms are neutral. Nucleus is positive. Okay? All right, so I think we've accomplished that goal. And again, if you just play around with it, oxygen flow. Man, as I change, the identity changes. Okay, that's going to be next. Do I have an atom yet? No. And now I've got, where are you going? What the heck? Get in there. Dude, seriously? I'm not doing this on purpose either. Dude, this is great. It ain't working. Hold on, get over there. There you go. Okay. I did not do that on purpose. So here I've got 10 protons, must be neon, 10 electrons. Atoms are neutral, same number of protons and electrons. Nucleus is positive. Why is it positive again? Because you've got neutrons which have neutral charge and positive protons. Okay, so I think we've accomplished that goal. Let me hit stop share for a second. So let's relook at that goal again to make sure we're okay. So today, so far in this video, we've talked about the location and charges of the subatomic particles, protons positive in the nucleus, neutrons neutral in the nucleus, electrons negative outside the nucleus. How and why atoms have a neutral overall charge? Why? Because you have to have the same number of protons and electrons, because all atoms, to be an atom, it must be neutral. Same number of positive particles as negative particles. Don't worry about the neutrons yet. And again, you'll learn next week, what if it's not neutral, then it's something called an ion, but just that's after spring break. Let's look at the third goal. Understand that the number of protons in an atom determine the identity of the element. I think we kind of saw that already, but let's focus in on that now, okay? Since we now know the location and charges, we now know you have to have the same number of protons and electrons. Let's take a look at how number of protons defines who the element is. And I think we saw a little bit of that. I'm gonna hit stop share for a second. I'm gonna pop up the interactive again. Okay, so let's reset this. Okay, so I will tell you this. The number of protons defines who the atom of the element is. Okay, so let's throw in one proton. Right now, because I've got one proton, we're in the process of making hydrogen. But I got to make sure it's an atom right now because we didn't get too far yet with ions. Atoms are neutral. Look at that. So look at this. I have an atom with one proton. And I'll just throw a neutron in there. You don't need to for this one, but that's fine. Don't worry about it. Just no neutrons are neutral right now. So now I have a neutral atom, one positive, one negative. So if I find an atom in this world, by some miracle, I scoop it out of the ground. You're not going to do that. Like find one. They're so small. And it has one proton, it's hydrogen. Every time an atom with one proton, every time it's defined as hydrogen, okay? So let's see, let's make another atom. I gotta make sure it's neutral. I gotta do the same number of protons and neutrons. So let's take a look up here. And if you notice on the side up here, there's some stuff on my screen that you can't see. It's blocking my periodic table. This right here is called the periodic table. Notice what happens. I'm gonna add another proton. Just watch up on the top screen. Look, I've got helium. Oh my gosh. Well, wait a minute, it's not an atom yet. I want an atom. Neutral. Wait a minute. So every atom in this world that has two protons is going to be helium. Look at that, and notice one and then two. One proton is hydrogen. Two protons is helium. Where do you think three would be? Take a look up here. Let's see. If I had a third proton, but I got to make a neutral atom, because again, the proton's going to go in the nucleus, so I'll throw some neutrons in there too. Let me throw in a couple. And again, don't show them the neutrons. Don't stress over those yet. Just know the charge and location. I'm going to throw another proton in here. What do you think we're going to get? Is it going to be neon, Ne? Is it going to be F, fluorine, O, oxygen? Let's see. Lithium. By the way, I know the answers. I'm just playing along. Lithium is the answer. So it goes 1, 2, 3. I have 3 protons. But wait a minute, I need to add another electron because atoms are neutral. Nucleus is positive. 3 protons, 3 electrons. So if I find an atom in this world that has 3 protons, and I could see that, no, you can't because it's impossible, but yeah, if I could see it, I have an atom of lithium. How exciting is that? So ultimately, as the number of protons changes, look at this, 4 protons gives me a beryllium atom. Where's beryllium? Right here. So I go 1, 2, 3, 4. See how this periodic table is kind of organizing stuff for us? And we'll get more into that later. Let's add a 5th one. What do you think it is? I bet it's going to be B for boron. We'll throw a couple neutrons in there too. But it's not an atom yet. I got to add an electron to cancel out the charges to make it neutral. Neutral atom. What do you think what do you predict? Take a look up here. Think, because we want you to think too, you know. If I had another proton looking at the pattern on the periodic table, what do you think I'm going to make? Let's see. Carbon, there you go. And I have to make sure it's neutral. If I had another proton, so if I find an atom with 7 protons, I have nitrogen. If I have an atom with 8 protons, I have, look, oxygen. You see the pattern? So we started at 1, 2, 3 protons is lithium, 4 is beryllium, 5 is boron, 6 protons is carbon, 7 protons is nitrogen, 8 is oxygen. So if any atom in this world that has 8 protons, done, oxygen. No ifs, ands, or buts. That's it. Let's do 2 more. So look at the pattern. Let's try to make, I guess, what? Fluorine. So if I have 9 protons, look at that. Make sure it's neutral. Throw in a couple of neutrons too. Again, we'll get into that with isotopes, and that'll be more next week. So look, I have fluorine. The number of protons, it's 9 in the nucleus, therefore it's got to be fluorine. It's got to be, and it's a neutral atom because atoms are neutral, nucleus is positive. And if we add one more, look at that. It's not an atom. Oh, that's right. Atoms are neutral, nucleus is positive. We see now we have 10 protons, neon. So I think you guys see how that works. So I'm going to hit stop screen share. And now I'm going to go back to our goals and reflect for a minute. So it says here, number 1, know the location and charges of the 3 subatomic particles, proton in the nucleus, positive. Hold on, am I hitting, wait a minute, share screen, hold on, my bad. There we go. So right here, protons, positive in the nucleus, neutrons, neutral in the nucleus, electrons, outside, negative, okay? And they'll make up the atom, they're really small. We call these sub. Sub means below or within, that's a prefix. Atomic, the atom, particles. So that means within the atom, the particles are proton, neutron, electron. You'd be amazed at how English is important with science, with prefixes and suffixes and root words. Goal number 2, how and why atoms have a neutral overall charge? Well, we said for it to be an atom, what has to be the same? What do we focus on mostly? Same number of positive protons and negative electrons, because we said atoms are neutral, nucleus is positive. Why is the nucleus positive? Because it has, the only charged thing in there is a proton. The neutrons are kind of chill. They kind of keep things chill. They're like a guidance counselor. And we'll get more into that next week. And we noticed, how does the number of protons in an atom determine the identity? Well, the number of protons do determine the identity of an element. So if I had, 1 proton, every time, if I have an atom with 1 proton, it's going to be hydrogen. It cannot be anything else. So again, think of it this way. The number of protons dictates who the element is. Okay, if I have 10 protons, I found an atom with 10 protons. Wow, look at that. I have what? Neon. Okay, so the number of protons determines who the element is. Okay, so you guys can continue on. I hope this video helped. Write down any questions you have and make sure to contact your teachers. Okay, guys, great job. Keep working hard, okay? The more you learn now, right, the easier it'll be in high school. So great job. Keep up the great work.